So that's going to be different than from yesterday. Yesterday we were evaluating expressions. Does anyone remember what it meant to evaluate? What do you got? Yeah, find the answer. So all of our answers yesterday were just like one simple answer, like 2 or 7 or -3. Today when we simplify expressions, we're not going to have our answer looking nice and neat, but we're going to we're not going to have our answer where it's just one number. We're going to try and get it as close to one number as we can, but because of variables, we aren't going to be able to. We're not going to know the values of our variables. So we're going to start off with our words here. So many words. We're going to start off with variable, which we defined yesterday. This will be the last time we define it. We're going to write a little bit more of an academic term for this. Joel, focus. They got to focus. A variable is an unknown number but when we don't know that number, what do we use instead? A letter. So it looks like a letter. So an unknown number, it looks like a letter. In math, generally, what is our favorite letter to use?
X.
X. But we like to use lots of letters, different ones. Right, when you look at your X, you always have to ask yourself why. It's funny. I'm funny. I'm so funny. All right, next up we got another word. Oh, I see a lot of people still writing. Sorry. Finish writing that up. I gotta tie my shoe anyways. So we like to use X and Y a lot in this class because X and Y go with a graph. When we graph things, we have an x-axis and a y-axis. But that's not to say that we don't use other letters. We like other letters too. All right, our next word is coefficient. Coefficient. What does coefficient mean?
Yeah, what does it mean?
It's a good question. So coefficient has a prefix,
What's that?
the beginning of the word.
Oh, okay.
What's the beginning of this word?
Co.
Co. Good. So we have that co is that beginning. What are some other words that have that prefix co? Codependent?
Coworker.
Whoa, coworker. That just really surprised me. Codependent, coworker, cooperative, right? Kind of has a co in it, or co-op. Okay, so what does it mean if you have a coworker?
You work with someone.
You have a partner. You work with someone. They're with you when you work. You might work at the same time. If you're codependent, that means you need somebody else. So most of you are like codependent on an adult. You live with an adult at home. You need them to make sure that you have somewhere to go home to. They file the taxes in your family, things like that, right?
No, they don't. I'm the man.
They don't? You're the man of the, so they're codependent on you?
Yeah, I'm the man of the
Makes sense. All right, so cooperative means you're working together. So coefficient is the number multiplied with the variable. So that with is kind of that idea that they're together.
Are you talking about how X is like next to another number?
Like a number like 2x. 2 is the coefficient. Good question. So with here, if you want to write in that word next to, it's going to look like it's just right next to it. Like 2x. 2 is that coefficient. It's with the x. They're connected. They're working together. And by connected, we mean that they're being multiplied. They're next to. They're coworkers.
They both get paid minimum wage.
Do they?
Oh, they do.
Shoot. Do they get double overtime, though?
No. They're
Oh.
both
Shoot.
brokies. Everybody. Merge.
All right. Next up, we have a constant. All right, what does it mean if you have a constant in your life or there's something that's constantly annoying you? Repeating.
That's what
What?
That's what
Repeating? It's like it's always there. Like if my brother constantly annoys me, that means it's happening over and over and over. It's almost like it's always happening.
He's bullying you.
And then
Well, if he's annoying me, some people can be annoying without bullying. Like if you chew with your mouth open,
But if
that's
he keeps on doing it repeatedly, he's just being bullied.
maybe. All right, so constant is a number without a variable. A constant is a number without a variable. Joel, put your phone away.
I don't even have one.
Oh, what are you doing?
Well, gotta keep checking on them.
Okay, write your notes down so you have them.
I already did.
You did? For the constant? I see variable and coefficient.
Yeah, you're right.
All right, and a constant, because the variable isn't part of it, we aren't multiplying it by anything. We know that it will stay the same. No matter what number we put in for that variable, that constant isn't going to change because it's not with the variable, it's separate. So if I say like plus 5, it doesn't matter what x is or y is, that 5 is a 5. It doesn't involve the x or the y, or the z or the t. How are we feeling? Bored?
No.
Cool.
Maybe.
All right, next up we got expression. We talked about expression yesterday. Does anyone remember what expression meant yesterday?
Show yourself out to the world.
Show yourself out to the world.
Yeah.
All right, so an expression is what? What did we say yesterday?
A feeling of yourself.
So sometimes like to feel your expressions as like emotions. What is it in the math context?
Math.
A math phrase. It doesn't have that equal sign. So today we're going to talk about it. We're actually going to show an expression as an example. Let's write 3x. I'm going to do it kind of big here.
Well, that's a lot of X.
Plus 2.
That's a lot.
And we're going to identify the different parts of this expression. So you're going to go down the cell. You're going to go where the windows are. He's right after the window. Yeah, after the double doors. He's right. Okay. Right. Come back if you get lost. Alright, so first up we have a variable. I'm going to go back to our notes here. Variable is an unknown number. It looks like a letter. I'm going to color code this. So I'm going to color my variable orange here. Variable. Edgar, put your phone away. You can look at your schedule in just a little bit. Alright, and what do we got for our variable here in our expression? Which one is our variable? Our variable is which part?
So what you say together down double doors?
X. So if you want to label that variable, you can. Mr. Kwan, do you want to take over? Okay, so that X is our variable.
Okay, we're going to label coefficient with green, or any color you like, honestly, as long as it's different from the first one. So coefficient is number multiplied with the variable, which is x. So coefficient will be number 3, right?
So we're looking at that number that's touching that X. It says that's being multiplied.
And can someone tell me what is constant? Which one is the constant? Yeah. 2, right?
What told you that 2 was a constant?
It's not, there's no letter beside it.
Good, it's just a 2. There's no variable next to it. It's just that number. So go ahead and match.
So it will make it easier if you label it as well. So the coefficient and the constant.
Crush it. Thank you. All right, now the other part of this that we want to know is the terms. So when we talk about terms, we're going to talk about parts. In this expression, there's kind of 2 big parts. What would be one of the parts? What's like the first part of the expression when you look at it? 3x. The 3 and the x go together. So the 3x together is a term. It's a part. You are a term, Jeremy. Yeah, Jeremy. Yep. All right, and what else would be another term? What's another part to this?
Plus 2.
Good, the plus 2, or just the 2 really, is a term. The plus is what we call an operation. So a term, which means part. Okay, so double check that you have all that information. That was kind of a lot. Double check that I have that written down. I'm going to give you a hint. It might be on your next test, which isn't for a while, so calm down. But there's almost a problem that looks exactly like this on your test, where you have to drag and drop those words. I don't do pop quizzes. I'm not going to try and surprise grade you. I want you to know where your grade's coming from. Right? When is the test? Like 2 weeks. Got a while. The 23rd or something. The 25th. I don't remember. Something for a while. All right. So now that we're talking about terms, we're talking about these parts of the expression, we have this thing called like terms. All right, so Mr. Kwan and I are like terms. Are Mr. Kwan and I exactly the same?
Yes.
Yes.
It's just a duplicate, copy paste.
Yep.
Yes.
Who's the original?
Not me.
Okay, we're not the exact same, but we're similar. We're alike. What's something that's similar about me and Mr. Kwan?
You both do math.
Good, we both do math. What else is similar? What? We're both teachers.
You guys like watching movies.
We both like watching movies.
You're both the same person?
We're not the same person.
You don't know that.
I think I do know that.
No.
Pretty sure if I went home and looked at myself in the mirror, I would know if I saw Mr. Kwan. That would be weird. Okay, but we have a lot of things that are similar, that are alike, but we're not exactly the same. So like terms is an idea kind of like that. It's parts with the exact same variables. All right, so for example, if I have a 4W, I want something with the exact same variable. So this one, I have that W is my variable. I'm going to use the same color I used earlier for variable, which was orange. You use your color if you want. Who's got a like term that would be with 4W? Another term that has that W. 7W. Good. Okay, now Dane's not allowed to give any more out. 7W, because you've been talking a lot, and I appreciate that. I want more people to talk. Okay, so 7W. Those are alike. Are they exactly the same? No, but they both have that W. No, give me another like term. 9W.
Thinking numbers and like doubles.
All right, can anyone think of a negative like term? You said negative 11, what? You didn't say anything, Jude? Liar, but that's okay. All right, who's got a negative like term for me? Just name any number. Q, you got a number for me?
Negative 20.
Perfect. Negative 20W. Thank you, Q. Okay, all of these have that W. Another thing that is a like term of those is just W. When I see just W, how many W's is that?
1, 2, 3, 4, 5.
Okay, let me say that again. When I see just that W, just W, what's my coefficient of that W? How many W's is it? 1. It's 1 W. So just W works. All right, now here's my question. Is 32 WX a like term?
Yes. No. No, it's not. No.
It's not? Why is this one not a like term, but these ones are?
Because it also has an X to it.
Good, that X tells us it doesn't work. Just because we see that W, remember it has to be exactly the same with the variables. All the letters have to match. So this one, after you write it down, 32WX, we're going to put a big X through it. It does not work. That's a non-example. When you X it out, you kind of want to see the background of it, so don't like scribble it out. You want to be able to see that we wrote it. So that way when you look back, you're like, oh yeah, that's right. All right, we have 2 more words. You guys are doing great. This is like not my favorite lesson in the world, but it's one that we have to do. So you guys are doing, you're crushing this. All right, next up we got commutative property.
That's 2 words.
All right. Okay, commutative property. It's kind of a long word, so take your time writing that down. Make sure you get it written down nicely.
This is not really like, I don't know. It's one number and then a letter and then another word and then another letter and it's like,
Maybe.
I get confused with properties.
Yeah, that's why we're doing them.
So confusing.
So confusing. All right, commutative property. When we think of commuters, or if you're going to commute to work, all of you commuted to school today. How did you commute to school?
I rode a bus.
You rode a bus. Who else commuted by riding a bus? Did anyone else commute a different way? How did you commute to work or to school? Your mom dropped you off. Anyone get dropped off by someone in a car or a truck or anything? Okay. Anyone else commute to work? Or sorry, I keep calling it work. I mean, that's kind of your work. Anyone else commute to school differently?
I rode a bike.
You did not. You said you rode a bus.
I rode a bike while
Same thing.
riding a bus.
Did any of you walk to school or ride a bike to school?
I walked a mile.
Any walkers in here? Yeah. I drove myself. Anyone drive yourself to school today?
So,
I don't believe you. All right, so commutative means to move. It means to like transport. You're moving around. So you're going from one place to another place. That's a commuter. When we use the commutative property, that means we're going to move terms. Okay. We have one more property, and then we're going to start an example, and then we have one more property after that. It's insane. It's a crazy set of notes. Associative property. All right, so sometimes when you go, like if you meet with a lawyer, it'll be like Johnson and Associates. What would that mean as a company if the company is called Johnson and Associates? Who works at that company?
John?
Johnson. Yep, the guy named Johnson. Is there anyone else that works at that company? Who are the associates? The people he works with. There's just too many to name. So this class is taught by Quan and Associate. I am an associate of Quan, or you could say Morel and Associate. We work together. But when we talk about being an associate, that means that we're associating each other with each other. We're associating ourselves with each other. Words. We're associating ourselves with each other. That means we're grouping ourselves together, saying we work together. Okay, so for associative property, we're going to group together. And in math, our most used grouping symbol, the one that you know mostly, is parentheses. So when we say group together, that means we're going to use parentheses to group them, put them in the same part. All right, now both of these properties we use when it's all adding. Okay, we can switch around adding problems, and we can group adding problems differently depending on what they are. However, we can't do that with subtracting. Okay, so for example, if I do 3 plus 7, what's 3 plus 7? 10. Yep. Is that the same thing as 7 plus 3? Yep. What about if I do 5 minus 2? 5 minus 2 is 3. Well, what's 2 minus 5?
Negative.
-3. We get different answers. So this only works when we have adding problems. We're going to work with it with subtracting problems. We're going to talk a little bit about that in this problem.
It can also work with multiplication.
You're right. We just don't usually do it with multiplication. It's kind of something you do when you're learning your math facts to use them. In this case, we're not going to do it with, we're not going to switch them around like that. You'll see. It'll make sense. All right, so number 1. Here's our first problem. How exciting. We're getting to the examples.
How many examples are there?
There are 3.
3.
3. But we have one more property we're going to talk about.
What?
I know, right? All right, so we're going to simplify. We have 16 plus 12c minus 5 plus 3c. All right, I'm going to use my colors again. This time I'm going to use colors that maybe are a little different or they don't stand for the same thing. So just erase your brain from the earlier part. What? Insane. All right, so as I look at this problem, there are parts of this problem that I want to put together. When I would simplify it, we're not going to get one answer at the end. It's not just going to be like 23. But we're going to have kind of different parts, but we want to combine some of those together. Which parts look like we could combine them or are like terms? What parts here match with each other?
12C and 3C.
Good, 12C and 3C. You guys can't just let Dana answer every question. All right, so 12C and 3C go together. You could circle them if you'd like to instead of using colors. You can use circles and boxes if you don't want to use colors. Is there anything else that goes together? The constants. Yeah. So the 16 is going to go with what? The 5. And that 5, though, isn't just a regular 5 because we have that minus in front of it. So when we think about that 5, we're going to move that minus sign with that 5. So we're going to move these parts around. We're going to put the parts together that match. So let's put our C's first. So first we'll have 12C. I'm going to move that there. Plus, and what do I want with that 12C? What was our matching part? 3C. Plus, now we're going to do our constants, our numbers without variables, because those are also like terms, because they have no variable parts. So 16, good. Hearing a couple people starting to whisper, find their voices. Plus, what's our other constant, our other like term? -5. Okay, with that whole -5 moved there. So if you need to draw your arrows to show where they went, you can do that. If looking at those arrows, you're like, whoa, that was crazy, don't draw those arrows. It's your choice. Okay, again, if you want to color code for a second, we have our 12C goes with our 3C. And our 16 goes with this -5. So now our like terms are next to each other. Which property was that told us that we could move them around like that? Good, commutative. So that was our commutative property that said that we could switch those around. Now here's the thing about germ DOS. When we add, this is all adding. When I add, I have to go left to right, which is great. It starts off well. I can do 12C plus 3C. I can add those together. But can I add those C's with a 16? No. So I want to group my like terms together. This part is usually not a part we write, or we don't take time to write it as a different part. So I'm going to write that 12C and 3C and put those parentheses around it. We're just going to do it for this first day, just to show what we're doing in our heads. We're putting those 12C and that 3C, those belong together. You belong with me. Why can't you see? Anyone? Eris, Taylor Swift? Cool. I'm a good singer. All right, I'm just kidding, I'm not. And then that 16 and that -5 go together. So now we should get one answer for our yellow part, the C's, and we should get one answer for our constants. What property did we just use there, though?
Associative.
Good, associative. So if you want to write that down, so you're like, why did we learn those terms?
So was that our second example?
No, this is all still one example. I haven't finished this one yet. Okay, now a lot of this is stuff that as we work through this, you're going to start doing this in your head. You don't take your time necessarily to write this out. I usually take time to write out my commutative. And then in my head, I just group these blues together, I group these yellows together. I don't actually write those parentheses. But it's something that we're allowed to do because of these properties, and that's why it's important we talk about this today. All right, so if I have 12 C's, I think I have C, 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 C. I have 12 of them, and I had 3 more C's, C, C, C. How many C's would that be altogether? 15 C's, yeah. So when we just add those coefficients together. So 15C plus, we did. We're going to go to the next page in just a second, and you can take a picture. What's 16 plus -5? Remember, when I have a positive and a negative, do we actually add them or subtract them? Subtract. So what's 16 minus 5? 11. And do we have more positives or more negatives?
Yeah, positive.
More positives. Okay, now I have a C. I have 15 C's, and I have the number 11. Is there a way I can combine a C with an 11?
One step equation.
Yeah, if we knew what it was equal to, but do we know what it's equal to? Doesn't tell us. So that's as simple as we can go. 15C plus 11. All right, I'm going to go to my next page because I'm running out of space here.
I don't even want to
I
write.
still have a half a page.
Okay, well then you just don't space your stuff out as nicely, which is fine. Then you keep going on your page. You do you, man. I'm going to go to my next page because I'm out of space because I spaced mine out. All right, our next property, we have one more property and then 2 examples, and we'll work our way through those examples kind of together, kind of on your own as we work. All right, are you guys good if I flip this?
Yeah.
No, you need it still?
Yeah.
All right, our next property is the distributive property. Last property for today. This one is probably the one that's the most important because we're going to talk about that property. We'll name it a lot of times. So if you've kind of zoned out on your notes, you're like, I don't want to write this down, it's not going to be helpful. This one for sure is super helpful. So you're going to want to make sure you have this written down.
Yeah, I don't want to write. I'm a risk not passing this trimester, just not write.
Captain America. The originals. Captain America, Iron Man, Spider-Man. All of them. Thor. I don't know. I like them all. Depends on the day. Alright, so when we do distributive property, when we distribute something, okay, we had laptop distribution this summer and at open house. What did that mean as a school when we had laptop distribution?
Laptop.
If you came to laptop distribution, what did you get?
Your computer.
Your laptop. So it was us handing out laptops to students. We gave them to each student. Now, that distribution has happened throughout the time that we've been here, so some people are still getting their computers, but we're getting to that point. So distributive means like to hand out or to give. So if I have A, and then in parentheses I have B plus C. Now eventually we'll get some numbers in there, so it'll make a little bit more sense.
And then plus C plus.
Yeah, all the things. Now, according to our order of operations, what do we have to do first? Parentheses. Can I add B and C together?
Yeah, no. You can't add that.
Are they like terms?
Yes, no.
They're different variables. They're different letters, so they're not like terms, so I can't add them together. But I still want to simplify this. So what we do is the distributive, and I always make noises with this. I go, pew. We're going to take that A. We're going to pew that A to B. We're also going to go back to A, and we're going to pew that A over to C.
Pew, pew, pew.
Okay, and what that tells us is that this is multiplying in front because it's touching. So now we're going to actually do that multiplying as long as I multiply to everything in that parenthesis. So I have A times B. That's that first pew. Plus A. We go back to that A and we're going to multiply it by C. Is this coming back to anyone? You're like, yeah, this makes sense?
Yes,
Yeah?
a little.
Do you have a question, Ada? Yeah. Yeah, can you fill out an eHealth pass? It should be working for freshmen now. All right, so if you want to write a description of distributive property, really what we're doing is we multiply to get rid of parentheses. Okay, so if you want a little written description of what the distributive property is or why we do it, what we do it for is to get rid of those parentheses. Because our order of operations tells us we have to do parentheses first. All right, we have two more examples. You guys are crushing this. I know this is a long day of notes. You guys are doing amazing. So long. Tomorrow you get the whole day to practice, though, so tomorrow we'll hardly talk. How exciting. Where did my pencil just go? On the ground. Thank you. All right, so here's example number 2, because we did example 1 on the other page. So example 2. I have 3 times the quantity of, remember quantity is like an amount, so separate amount, of 6K plus 2. And our goal is to simplify that. So if we were to follow our order of operations, can I add the 6K and the 2 that's in my parentheses?
Sure.
You can add K's with 2's?
Yep.
Only if that 2 also has a K.
Or you can add 6 and 2 to get 8, and then you add the K to it.
But the 6 isn't a 6. The 6 is just saying that there's 6 K's. K, 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 K. And then there's a number 2. So we can't put those together. So because of our order of operations, we can't do that inside part. So what we need to do is we need to distribute. So we're going to take that 3, and we're going to go pew to the 6K. And we're going to go pew to the 2. You don't like that noise? Pew, 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 pew. So we're going to take that 3, and we're going to multiply it by each part. So underneath that, I'm going to just rewrite it as multiplication. Again, eventually, we're going to get to the point where we don't have to write this step. You'll get to that point where you just write the answer. And some of you might already be there. So we have 3 times, what's the first part?
3 times 6K.
6K. Now, if we give the 3 to the 6K, we distribute it, we also have to give that 3 to the 2.
Because the 2 is jealous.
Maybe. Could be. Now, even though we can't add like terms, or when we have a number and a variable, we can't add them together, but we can multiply. This is saying if I have 6k 3 times, a 6k, 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 how many k's would I end up with? Good, 18. Because I have 3 of them. And then what is 3 times 2? 6. So our answer there would be 18k plus 6. Alright, we have one last example. You guys are crushing this. We got about 5 minutes left, and we should finish this example with some time to breathe at the end. Maybe. Depends. Alright, last example, number 3. We have 6 minus 7 times the quantity of 3y minus 4 plus 2y. So now we took all these little parts, these properties we did, and now we're going to combine them into a more complex problem.
Just add more numbers to make it complex.
I mean, I could, but I'm not going to today. All right, so as we look at this, we're going to start off with our order of operations, which order of operations starts off with parentheses or grouping symbols. Do we have grouping symbols?
Yes. Yes.
Yeah, we do. Can I do the 3y minus 4?
Yes.
Yeah. Wait, no.
Are they like terms?
No.
Yes.
No.
I wish.
I wish. It would make it easier, but it's not. So I can't actually do 3y minus 4. So in order to get rid of my parentheses, I'm going to have to do multiplying. What number am I going to multiply those parentheses by?
7.
Close, not just 7. That 7 is secretly
It's secretly
a negative 7 because we have that minus. So as we distribute that out, we want to distribute out the negative 7 because it has that minus in front of it. So we're going to go pew, pew. If this looks familiar to you and you want to try and work ahead, go ahead and work ahead and double check your work. So I'm going to show my work here for this first one. I have negative 7 times, what's my first part? 3y. And then I have that second pew. So we're going to do negative 7 times, what's my second part?
4.
Negative 4. Good. That minus gets attached to that 4, that negative. Alright, at this point you could use a calculator if you'd like to. I think I got some human calculators in here.
that'd be
What's negative 7 times 3?
negative 21.
Negative 21 y plus
28 y.
negative 7 times negative 4.
Oh, no, 32.
28. 28 was right. Is it positive or negative?
Positive.
When I have a negative times a negative, our answer is positive 28.
Just always think about
Oh,
the two
Tom, you
negatives.
cannot mess with me.
Always think about
You
the
cannot mess with me.
two negatives making a positive.
Sometimes, yes. Alright, so if I have that 6, unless you're adding them, I'm going to put that 6 in front with a plus sign. That drops down. And I have this 2y attached to the end. So is this as simple as we can make it? Or is there more we can do?
There's more you can do.
There's more we can do. What more can I do? What do you got, Dane?
21y plus, negative 21y plus 2y.
Good, we have this negative 21y and it has a like term, which is that 2y. Are there any other like terms? The 6 and 28. So we're going to rearrange them so they're together. So I have negative 21y. I'm going to put that together with the 2y. And then we're going to put the 6 with the 28. Alright, and then we just add them. Negative 21 plus 2? Negative 19!
No, we're leaving. We don't
Alright.
do more.
I thought we got out in like 5 more minutes. I'm sorry.
No. We get that up here right now.